So we're going to state, let's make this a little bit bigger. So we're going to formally state that the polynomial value of a at 2 is equal to 5. Okay. So far, so good? Yeah. Not too complicated? All right. Go back to Desmos. Turn off the first one. Turn on the second one. And then again, use your fingy. Click on the 2. And this time, it snaps right to the y-axis, x-axis, because y is equal to 0. Okay. So b of 2 equals 0. Okay. Let's try c. You might have already noticed that my c looks a little different than yours. You try moving 2, find the y value of 2, it doesn't work so good, does it? Oh, look what I did. I changed it into a table. I changed it into a table, and then find the value of 2. So go here, change it into a table. Okay? And it's going to give you all the values from -2 to 2. We don't want all of them from -2 to 2. The only one we want is 2. Okay? And when you find that, you should find it is 105. You see why it was kind of a pain to try? It's like, I don't want you to change the window. So, easiest way to find a value of a polynomial when it's not within your window is to change it into a table, plug it in. Okay? So, because here's my new graph. This goes way too high for me to see it within that window because my window's only going up to like 8. Okay, so C of 2 is equal to 105. Okay. Yep. So we're not going to do any fractions or decimals, at least. Not today. 105. Okay. So I want you to take a few moments and find B, E, and F. Find the value of 2. Sometimes you'll have to change it in a table, and sometimes you won't. So find the values for D, E, and F at 2. Turn this one off. I turn this one on. That looks like 0. So it's the same as this one. I'll do a little Control A, Control C, Control V, and change the B to a D. Okay. All right. E. So turn this one off. Turn this one on. Hey, that looks like it's also. But you got to be careful. You can't just assume every single time it's going to be 0. So base, and this one is now E. But I'll tell you, the next one is not. Did anybody get the next one? What was it, Joseph? Yeah, so you go here. You plug in 2. That's going to be a very large negative number. Okay, mostly because of that 27x squared. You're subtracting 27 times 2 squared. That gets kind of big. And then you're subtracting 101 times 2. So 324. So it literally like drops down. But what happens eventually, it does come back up because this is a 4th degree equation with a leading coefficient that's positive, which means it should be up on both sides. Okay? All right. So F of 2 is equal to -324. So we have now done number 1. I'm not going to make you do 6 divisions. Okay? I'm going to divide you right along here. Okay? So Angeli, this side, Joseph, Camilla, Daniel, this side. Okay? So this side, A, C, E. This side, B, D, F. You are going to divide by x minus 2. I would not recommend long division. It's going to take too long. In fact, I'm going to force you. This is the only time I'm going to force you because I want to get this done quickly. I want you to use synthetic division. What value should you use? -2 or +2? +2. Okay. So you're dividing 3 times. ACE by 2, BDF by 2. Go ahead and do those synthetic divisions.
Wait, I only know how to do the long.
You did number 2 and you found the remainders. What did you notice about the remainders? they were the same as the values of the polynomial. That is called the remainder theorem. Okay? So let's kind of just flesh this out a little bit. Okay? The value of a polynomial, I always care. Polynomial is equal to the remainder remainder. Okay, so more explicitly, we use some symbols here. Okay, P of x is equal to the remainder. Okay, so that's it. So questions? Yeah.
Is it only equal when you divide it by 2?
It's equal when you divide by a linear factor. Okay. So this works when you have a linear factor. Good question. So our linear factor in this case was x minus 2. It's really whatever your factor is and what makes that 0. Okay. So in this case, what makes x minus 2 0 is 2. If I have something a little bit more complicated, and we'll talk about those tomorrow, we'll get into it. But really the only thing you need to worry about is when you're doing the division. Synthetic is probably the easiest. Your remainder will be equal to the value of the polynomial. Which leads us to the idea that we talked about at the beginning, was when something doesn't have a remainder, what is that called? A factor. Okay, so the factor theorem really just states if there is no remainder, then in this case x minus 2 is a factor, then the divisor is a factor of the polynomial. Yep. Well, we use 2 as an example, but we're talking about in general, okay? And that's about it. That's the new stuff. We're just taking this concept. We knew how to plug numbers into a polynomial. We knew how to do long division. We knew how to do synthetic division, the box method. We just put them together, understood that the remainder is the value of the polynomial, and if there's no remainder, then that divisor is a factor. I mean, that's something we kind of knew with numbers, but we haven't really explicitly stated with polynomials. That's it. Okay, so now we're just going to practice a little bit. So we're going to do like a little Jeopardy action. Okay, you're given the answer. We need to come up with the question. So I'm going to start you off. Okay, so let's say something along the lines of, if we know f of x, okay, so f of x is equal to, now the issue at hand is we have the f of x, the polynomial, in factored form. More likely than not, it would be in standard form. So I want you to take a moment and calculate it in standard form. So go ahead and multiply out. So if it were me, I would suggest multiplying these two first. So do those 4 multiplications. You're going to get a quadratic, 3 terms, and then multiply what you get here by that. So go ahead and take a minute or two and get that done. So I'm going to put this on a blank. And you know what? I want to put blank. We can just add a page. Little copy action. Go to the end because we want some space. And let's add a couple pages. So you can always add pages to Cami if you did not know that. So come down here,
Yeah, do it.
All right. Paste. All right. I suggested do these two. So I'm recording.
Oh, sorry.
You're lucky it was paused. In other words, how can I get from here to there? How should I structure my question so that I get 2x minus 1 times x plus 2 times x minus 8? We have done this before, about 3 or 4 times. Tristan Wright was the only person, third period, who properly came up with this question. No pressure, Avery, but that's the seat he was in. So, see if you can come up with the remainder of this question. Okay?
Wait, do we do it up here?
Yeah, I'm just going to put it in the second box.
No, I said that we do it up here.
No, we have not done it today, but we've done it in the past. I've asked you this question in the past. If I give something to you in standard form, and the answer is that, how do I ask the question? There's a couple different ways you can ask it. We've asked this question at least 3 or 4 times in the past.
Since you want to be like that?
Emilio's already gone into the research mode.
What are you gonna do?
Don't follow this way.
No. Now.
Don't follow you. Trust me, you're gonna want like follow baby.
Exactly. You know what my follow.
If you don't shut your
Rich man.
Camera.
Oh, yeah. Okay, Juan's got it. So we're gonna modify a little bit.
So I have 13
Actually do it. All right, Camilla, coming. There we go. That's what I wanted to see. Nice. Let's modify this a little bit. That's good. All right, we got 3 people. That's better than third period. Okay. So which one did I say I like the best? What was it? It's Camilla's, right? All right, Camilla. What is it?
Rewrite f of x as a product of linear factors.
Okay. So rewrite f of x as a product. That's the multiplication part. What was the rest of it?
As a product of linear factors.
Linear factors, okay? And this was a little extra something because Joel was a little more hardcore. What did you not have, Joel? The linear, okay? The linear is really specific. That means what should I not have in any of my answers? No exponents. So yours, we could have multiple answers. Because if we just divided the x minus 8, we could do x minus 8 times whatever the answer was there. Okay? But with Camilla's, it's very specific. We can't have any exponents. Okay, so hers has to be linear. And then, William, you flashed a 3 at me. Why? Why'd you flash a 3 at me, William?
Oh, because linear's 3.
Linear's not 3, but it's a third degree, which means if I'm given 1, how many times do I have to divide? 2. To get from 1 factor to 3 factors, I need to divide twice. Okay? Do you think I'm going to be asking you to do that on the next problem?
I hope not.
Walked right into it, didn't you? All right. This one takes a little bit of work. But wait, there's a lot more things than 3. Yes. Look at the next question, see if you can figure out how to work that out.
Are we just doing the same thing? Like we're creating another problem?
So we're not creating the problem. You're doing this problem. This is actually the last problem. with a different polynomial. Oh, it doesn't give me the factors. You're right.
Oh no.
Oh, yes.
Wait, I'm so confused.
So find the linear factors that would produce that polynomial.
Wait, -1 is a factor. Wait. Because up here, Mr. Trailer, up here.
Set it up. You're gonna help him set it up. So Jamie had already figured out something. What did you figure out, Jamie?
That -1 is a factor.
How do you know -1 is a factor?
Because it's equal to 0.
Because it's equal to 0. So anything that's not equal to 0, we are not going to use. Okay? So I like Jamie's idea because -1 is a little easier. So start with -1. Do some division.
Wait, if
Okay.
you're doing regular long division, do you do x minus -1?
Or x plus 1. Okay? So find the answer and then see if you can figure out where to go from there.
Wait, so if I use synthetic.
Okay, here we go.
Can I help?
Line. Drop the 2. Multiply. Add. Multiply. Add. Multiply. And how do I know I'm on the right track?
Because it's 0.
Got a remainder of 0. If I am told something is equal to 0, that means it's a factor, which means my next division should give me a remainder of 0. If I didn't get a 0 here, I did something wrong. Okay, how many factors do I have so far? I have x plus 1, and I have 2x squared plus 3x minus 9. But it's supposed to be linear factors. Is 2x squared plus 3x minus 9 linear? So we need to do it again. Oh no, what am I supposed to do now? Well, I use this one. Are there any other factors I could possibly use? -3. So now I just do it again. Okay? Oh, let's go blue. So -3, drop the 2, multiply, -6, add, -3, multiply, +9, and once again, my remainder is 0. So now I have all of my factors. I have -1, which translates to x plus 1. I have -3, which translates to x plus 3. And my last one is 2x minus 3. So some of you did beautiful work, and you blew it with one of your signs. So the way you can always check is you put in the original polynomial, you put in your product of your linear factors, and they should match up. And if they didn't, then it's probably check your signs first.
Wait, do I have to rewrite all this on again?
So on your